Hello, class. Welcome to another Office Hours video. I've been getting a few different questions about optimization, so I'm going to post a few more videos of different examples. So I think the most requested one so far has been this question 8. I think largely because it is very long-winded, so I'll read it out loud and explain what I've written so far. So it says, a construction company has adjoined a 27-foot square rectangular enclosure to its office building. Okay, so I have a building here, and then I have a fence like this. 3 sides of the enclosure are fenced in. The side of the building adjacent to the enclosure is 270 feet long, and a portion of this side is used as the 4th side of the enclosure. What this is really doing is giving me an additional constraint that I can't make this side of the fence longer than 270 feet, so I'll have to take that into account as I work through the problem. It then goes on to say, let x and y be the dimensions of the enclosure where x is measured parallel to the building, and let L be the length of the fencing required for those dimensions. Okay, so here we go. There's x, there's y. X is parallel to the building. First it asks, find a formula for L. So all it's asking is, what is L in terms of x and y? Well, L is the amount of fencing, so L is x plus 2y. Then it says, find a formula that expresses L as a function of x alone. So if I want to do that, I need to use my constraint. So I'm going to go ahead and switch colors for variety and solve the constraint. So when I solve the constraint, I'll get y equals 2700 divided by x, which then means I can rewrite this L as being x plus 2 times 2700 over x, which is to say that L is x plus 5400 over x. Okay. It then asks, what is the domain of the function in part B? Namely, it's asking, what are the reasonable choices that I could make for x? Now, the smallest choice I could reasonably make is 0, although that 0 isn't really included. So you can put an open parenthesis there for the 0. And then what's the largest it could possibly be? Well, the largest x could possibly be, since x is here running parallel to the building, I can't make it larger than the building. So the largest I could possibly make x is 270. And I put a square bracket here to indicate, hey, I'm enclosing that. And actually, that's all this question asks us to do. We don't actually have to go through and finish the problem, but if we did have to finish the problem, what we'd have to do is take the derivative here of this function, figure out where the critical numbers are, that is, where the derivative is 0, and then when we were checking our answer, we'd have to make sure we checked the critical number if it was inside this interval, and we'd also have to check this 270 endpoint and see which was better. All right. But for now, I'm going to wrap up there, because that's what the question asks. I'll be back later with more of these as you work through the optimization problems this week. But until next time, be well.